So here we are going to discuss an example related to nodal analysis. We have already discussed the basic concepts related to nodal analysis in the previous video. So in this video we are going to discuss how to apply nodal analysis to find out the node voltages or whatever parameter is being asked. Now in this question we have a simple circuit, not so simple but still it's a simple and straightforward circuit. Now we have to determine the node voltages. So in order to determine the node voltages, the first step is to determine which points are the nodes. Okay, see here at this point it is a meeting point of a number of circuit elements, 2 ohm, 4 ohm and 5 ampere current source. So obviously this is a node. Let us call it node number 1. Here also, here 4 elements are involved, 4 ohm, 6 ohm, 10 ampere, 5 ampere. So this is node number 2. We have studied in the previous video that nodal analysis is based on Kirchhoff's current law. So in order to apply Kirchhoff's current law, we must have currents. So here we have two independent current sources, 5 ampere, 10 ampere, but we have to assign arbitrary current values to 2 ohm, 4 ohm and 6 ohm resistors. Excuse me. So let us assign that the current flowing through this 2 ohm resistor be I1, current flowing through this 4 ohm resistor is I2, and the current flowing through the 6 ohm resistor is I3. Okay, this is I3. Now let us apply nodal equation, means KCL, at this node 1. So here you can see 5 ampere is moving towards the node 1, while I2 and I1 they are moving away from the node. So nodal equation will be I1 plus I2 is equal to 5. Okay, I1 plus I2 is equal to 5. Let the voltage at node 1 be V1, the voltage at node 2 be V2. Okay, V1 and V2 are the node voltages at point 1 and 2. So we have already discussed that current flows from a higher to a lower potential. So this current I1 is actually can be written as V1, which is the voltage at node 1, minus the voltage at ground, which is 0 volt, by 2 ohm. So it is V1 minus 0 by 2 I1. Then I2 is flowing between points 1 and 2. So it is V1 minus V2 by 4 plus V1 minus V2 by 4 is equal to 5. Okay. Now let us, in order to simplify this equation, let us multiply 4 on both sides. If you multiply 4 on RHS and 4 on LHS, it will become 2V1. Okay, we are multiplying 4 on both LHS and RHS, that is 4 into this, and here also we are multiplying 4. So it will become 2V1, okay, 4 by 2 is 2, plus V1 minus V2, here 4 and 4 got cancelled out from the numerator and denominator, is equal to 20. Okay, that implies 3V1 minus V2 is equal to 20. 3V1 minus V2 is equal to 20. So let us mark it as, this is equation 1, this is as equation 2. This is an important nodal equation. Okay. Next, let us apply KCL at node 2. In node 2, I2 and 10 ampere, they are moving towards the node. Okay, I2 and 10 ampere are moving towards the node. 5 ampere and I3 are moving away from the node. Okay, so I2 and 10 will be on one side. I2 plus 10 is equal to I3 plus 5, or we can write it as 5. Okay, we have taken 5 to the LHS and I2 to the RHS is I3 minus I2. 5 is equal to I3 minus I2. Let's call it as equation number 3. That implies I3 is V2 minus V ground, which is 0 volt, divided by 6. Okay, it is flowing between point 2 and ground. So it is V2, I3 is V2 minus ground, which is 0, by 6. I2 is V1 minus V2 by 4. Okay, V1 minus V2 by 4 is equal to 5. Okay, now if we multiply a common thing so that this denominator get cancelled out, let's say say 60. Okay, if we multiply 60, then we can cancel both the denominator and turn it into a simple equation. Okay, so let's say that implies 60 into V2 by 6. Okay, and here it is minus V1 minus V2 by 4 is equal to 5 into 60. That implies 10 V2 minus 60 by 4 is 15. 15 into V1 minus V2 is equal to 300. 60 into 5 is 300. Okay, if we want to further simplify it, we can divide it by 5. Okay, we can divide it by 5, the whole equation. It will become 2V2 minus 3 into V1 minus V2 is equal to 60. Okay, 2V2, we have divided this equation by 5 on both sides. 10V2 minus 15 into V1 by V2 by 5 and 300 by 5. So it became 2V2 minus 3 into V1 minus V2 by 60. So it will become 2V2 minus 3V1 plus 3V2 is equal to 60. That implies minus 3V1 plus 5V2 is equal to 60. Okay, so this is the second nodal equation that we got. Okay, so these are the two nodal equations. 3V1 minus V2 is equal to 20, minus 3V1 plus 5V2 is equal to 60. Now we have to solve these two simultaneous equations to get V1 and V2. Now these are the two nodal equations that we got by applying the KCL or nodal analysis at the nodes 1 and 2. Now we have to solve them, solve these two simultaneous equations involving two variables to get the values of V1 and V2. Now if we look carefully at these two equations, we can see that here it is 3v1, here it is minus 3v1. So we can directly get the value of v2 just by adding these two equations. Suppose we add equation 1 plus equation 2. So it will become 3v1 and minus 3v1 will get cancelled out each other. So here it will be 5v2 minus v2, okay, be 60 plus 20. Okay, we are simply adding equation 1 and equation 2. So that implies 4v2 is equal to 80 volts. That implies v2 is equal to 80 by 4, 20 volts. So we have found the value of v2. Okay, we have found the value of v2. Now we have to get the value of v1. So we can substitute this v2 in equation 1 or equation 2. So let us substitute it in equation 1. So 3v1 minus 20 is equal to 20. Okay, that implies 3v1 is equal to 40 volt. Implies v1 is equal to 40 by 3 volts, which is equal to let's say 3 into 13, 13, 26, 39. So it is 13.33, around this much value. So v1 is 13.33, 40 by 3 is 13, 26, 39. Yes, 13.33 volt. This is the value of v1. So we have found the value of both v2 and v1, the two nodal voltages. Okay, so again let us just have a quick recap of what we did. First, we assigned nodal voltages to these 2 points. We identified the 2 nodes, assigned 2 nodal voltages v1 and v2. Then we assigned arbitrary currents to the branches 2 ohm, 4 ohm and 6 ohm. Then we wrote the nodal equation or the KCL equation for the respective nodes 1 and 2. Then we represented the unknown currents in terms of higher voltage to lower voltage divided by resistance, okay, as current flows from a higher to a lower potential. Then we got the two simultaneous equation by simplifying the nodal equations. Then we solved the simultaneous equations to get the two nodal voltages v1 and v2. Okay, so this is all you have to do in nodal analysis. It can be a little time taking, but you should have some patience. It takes some practice. Okay, practice as many problems as you can, and then you can have command over this concept and any concept for that matter. You need practice and patience. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.